building here is we want to build proof singularity. And what does it mean? We think the Ethereum is a human civilization's final. Great. We think Ethereum is going to be our human civilization's final settlement layer. So in the past 10 years, we have already been built decentralized censorship resistance ledgers, and it support like codified Turing complete settlements, right? Like basically what's next. So the thesis here is that since Ethereum is our civilization settlement, the final form of settlement is actually about proofs. More specifically, like proof can be used for like succinctness, scalability, and also privacy. And the ultimate form of blockchain would be only serve two purposes. Like one purpose is data availability, and one purpose is just like only like verifying zero-knowledge proof, right? It's just like pushing out the complexity from the base layer to the edges so that we have like a more robust base layer. So this is my strong thesis here. I do think proof is going to power the next 10 years Ethereum. Please raise your hand if you haven't heard like any of this project. Okay, no, that's good, right? So you can see it actually like powers the next 10 years Ethereum in different kind of ways. We have the scale solutions like ZK EVM like Scores, ZK Sync, Polygon, Nia. We have privacy like Somophore, like Macy, Nocturne, Aztec. We have oracles like Axiom, Lagrange, Succinct, HyperOracle, for example. The problem here is that the verification cost is very big right now. Even if we're envisioning the future, the prover cost will getting down over the time, but the verification cost will not. It's very obvious because why Ethereum is such a great decentralized ledger is because of decentralization. Like you cannot make the verification costs cheaper unless you sacrifice decentralization, like allowing each validators running like a much better hardware configuration. So more specifically, if you want to verify a gross 16 proof, you need like 250K gas. And using a very moderate setting, like 20 GWA gas fees. By the way, the running average in the past bear market is like 26. And also like a 2,000 USD ETH price is going to be $10 US. And if you verify a Halo 2 KZG proof, it's going to be $16. And if you verify a Stark proof, it's going to be $60. Right? So I think Vitalik famously said, do I want to pay $20 for adding privacy? Probably using it as a gimmick, but not just like doing it every day. So we have a problem. That's why we're building Nebra. We try to bring the proof singularity to Ethereum. The quick question here is, how can we make ZK cheaper on-chain? The answer is using ZK itself, right? It's kind of like using magic to constructing more magic. So this is the first product we're building. We call Nebra UPA. It's like a universal proof aggregator. So from the very high level, the UPA takes proofs from different circuits. For example, it can come from a ZK EVM. It can come from like storage proof. It can come from ZKML. It doesn't matter. That's why we call it universal. And all the proof getting fed into the UPA, and will generate a single aggregated proof. And this aggregated proof is settled on-chain. And now, instead of paying, like say, 32 proofs, you only paying the verification cost of single proof. And all the proof verification costs getting amortized. And the more proof you aggregate, the less cost you have. And that's from a very high level what Nebra is. But of course, things are not that simple. And we're actually a decentralized protocol. So the Nebra protocol has several parts. We have the smart contract. It's a permissionless way you can interact with us. You can just submit your proof to our smart contract instead of directly constructing your own verifier contract. And it's going to be deployed on all the major L1 and L2 EVM chains. So, and then the magic happens off-chain. We have a coordinator, and this coordinator will distribute the proving work to a distributed prover network. So the aggregated proof will be generated and pipelined to Ethereum. So we have three high-level design goals of the protocol. First is permissionless, so anyone can use us. Second is censorship resistance. So we'll have a very similar censorship resistance guarantee compared with all the major L2s, which is we're using the inbox mechanism via forced inclusion to like settle the proof on chain. And last but not least, we're actually going to be progressively decentralizable. So that's the protocol, right? So how do you use us? And it turns out to be using us is extremely simple. On the left-hand side is how you verify a zero-knowledge proof today on Ethereum. For example, you deploy your verifier.stall contract, contains a bunch of cryptographic calls to Ethereum EVM per compose. You just like call the verify proof function. And by using us, you just need to take two steps. The first step is to register your verification key. For example, you register your VK so that we know what kind of proof you are verifying. And then you just submit the proof to our smart contract called submit proof function. And the contract we call it Saturn. And then that's it, right? So you subscribe to an event, your proof is verified, and once the aggregated proof is verified on Ethereum, and you don't have to trust us. So coming for Nebra product, we're not only just building the proof aggregation protocol, it's a full-fledged product. The first one is a smart contract. You can see we're already running in the internal testnet. It's verified quite a bit transactions. It will have a very easy TypeScript SDK you can integrate with your smart contract. And you will also have a Nebra proof explorer to checking the status of your proofs. So I will be really quick and skip the technical highlight part. So what happens inside is that we're using two layers of Halo 2 recursive proof systems, like two-layer aggregation. The core technique we're enabling the Nebra can be actually aggregating proof here is some like advanced like mathematics. So we're using the Chinese remainder theorem-based field simulation with lookup so that the recursive proof can be efficiently verified. And also on the distributed system side, we're actually using pipelined, which means it's an event-driven architecture, kind of each prover running as a microservice. And whenever there's a trigger on chain, like the server starts, and also it's pipelined through blocks. And also it's distributed so that we can add and removing like GPU provers on the fly. And last but not least, we're actually using GPU accelerations to accelerate the Halo 2 proof aggregation. And we're also looking at Nebra UPA v2, which is we're actually building a proof aggregation VM. And it will enable much universal proof aggregation, which means we can support multiple proof systems as well. Currently, we're only supporting Gross-16. We're going to support Planck, Stark, and so on, like GKR, for example. And there are some key like technology innovation to enable even faster aggregation, like majorly from like cycling curves, like to get rid of some of the non-native arithmetics, right? Basically, Aztec have a similar technique called Goblin Planck. And also, we are going to using more efficient polynomial commitment schemes designed and optimized for like less recursion overhead. And of course, we're using more efficient lookups. So last but not least, I will highlight some more use cases than just like making the proof cheaper. So for example, if you want to enter a light club in Zuzulu at 2030, right? So I don't think you only need to aggregate a proof. You want to compose proof. By composing mean you want to atomically compose different kind of proof together into a single proof so that you can get your business logic done. For example, if you want to enter this light club, you want to have a proof of humanity, you want to have a storage proof that you're holding some NFTs, and also you want to have a proof that you are not in the blacklist of the light club, for example. And then that's just like really more use cases here. And so I think like Vitalik in 2022 has a very, very similar vision. Like he actually envisioned we're going to have putting single aggregated block proof per block. But actually, I do think this vision can be realized maybe even more like sooner than Vitalik realized. Yes, so this is a teamwork and this is my talk. Is there a question phase or yeah, like feel free to catch me after if you have any questions. Yeah, thank you.